If you tightly glue your web server directly to your database, a sudden spike in traffic can take down both systems at the same time. The web server gets overwhelmed, starts hammering the database with requests, and suddenly your entire application explodes into a giant 500 error. That is called a cascading failure. One overloaded component drags everything else down with it. To build resilient cloud applications, you have to break that chain and separate your services. That is where Amazon SNS and Amazon SQS come in. Both services help applications communicate, but they solve different problems and use completely different communication styles. Amazon SQS stands for Simple Queue Service. Think about a crowded coffee shop during the morning rush. Customers place orders faster than the barista can make drinks, so the orders wait safely in a line. The barista grabs the next ticket only when ready. That is exactly how SQS works. When your application gets flooded with requests, it can drop messages into an SQS queue instead of forcing the backend system to process everything immediately. Your worker servers then pull messages from the queue one at a time at their own pace. That phrase matters: pull-based. The workers decide when to grab more work. If traffic suddenly spikes, the queue grows longer, but your back-end systems stay stable because they're not forced to process everything instantly. SQS is not about making systems magically faster. It's about making them survivable under pressure. Now compare that to Amazon SNS, the simple notification service. SNS works more like a megaphone. You publish one message to an SNS topic, and SNS instantly pushes that message out to multiple subscribers at the same time. That's why SNS is called push-based. One event can trigger many different actions simultaneously. An SNS topic might send a text message, trigger a Lambda function, email an administrator, and notify another application all at once. So here's the simplest mental model to remember. SQS stores work safely in a queue. SNS broadcasts information to many destinations. Now let's talk about why engineers choose one over the other. You use SQS as a buffer or shock absorber between systems. Imagine your order processing server goes offline for maintenance. Without a queue, incoming orders could fail immediately. But with SQS, those messages simply wait in line until the server comes back online. Nothing gets lost. That separation dramatically reduces the blast radius of failures. SNS solves a different problem. It's designed for immediate broadcasting. If a security alarm triggers, SNS can instantly text your phone, email the operations team, and trigger automated responses at the exact same second. For AWS certification exams, the keywords are extremely important. If the question mentions decoupling, buffering, queues, or pull-based communication, think SQS. If the question mentions pub/sub, fan-out, notifications, or push-based communication, think SNS. Now, here's where modern cloud architecture gets really powerful, combining both services together. Imagine a customer clicks Buy on an e-commerce website. The website sends one event to an SNS topic saying, "A shirt was purchased." SNS immediately fans out copies of that event into multiple SQS queues. One goes to inventory, another goes to shipping, another goes to analytics. Now, each back-end service processes messages independently by pulling from its own queue. If the analytics system slows down, shipping still works fine. If shipping goes offline temporarily, inventory processing continues normally. That independence is the entire goal of decoupling. Instead of tightly chained systems dragging each other down, every service can scale, fail, recover, and process work separately. You broke the chain from the beginning of the video. Now your architecture is resilient, scalable, and fault-tolerant. But there's still one more piece to the puzzle. We're still managing servers to process these messages. What if you could run code without provisioning servers at all? That's exactly what AWS Lambda solves.